on circular motion. Part 2. Question number 1. What is tangential acceleration? And it is denoted by AT. Options are A. The acceleration that changes the direction of velocity. Option B. The acceleration that changes the magnitude of velocity. Option C. The acceleration that is always perpendicular to velocity. Or option D. The acceleration that is directed towards the center of the circular motion. The correct answer is option B. The acceleration that changes the magnitude of velocity. Explanation. The acceleration responsible for changing the magnitude of velocity is called the tangential acceleration. So, this acceleration is always directed along or opposite to the velocity. Question number 2. What is the relation between angular acceleration alpha and angular velocity omega? Options are alpha is equal to omega cross t. Option B, alpha is equal to d omega by dt. Option C, alpha is equal to minus omega square r. And D, alpha is equal to t times omega. And the correct answer or option is B, alpha is equal to d omega by dt. And explanation, the angular acceleration alpha is defined as the rate of change of angular velocity omega with respect to time. Question number 3. In a non-uniform angular circular motion, what is the direction of the angular acceleration alpha? Option A, always perpendicular to the axis of rotation. Option B, along or opposite to the tangential velocity. Option C, always along the axis of rotation. Or option D, opposite to the direction of angular velocity. And the correct answer is option C, always along the axis of rotation. Explanation. Even in a non-uniform circular motion, as the particle remains in the same plane, the direction of angular acceleration, which is denoted by alpha, is always along the axis of rotation. Question number 4. If the speed of an object in non-uniform circular motion is increasing, in which direction is the angular acceleration alpha? Option A, opposite to the direction of angular velocity omega. Option B, along the direction of angular velocity omega. Option C, perpendicular to the direction of angular velocity omega. Or option D, opposite to the tangential velocity. And the correct answer is option B, along the direction of angular velocity omega. Explanation. When the speed of an object in a non-uniform circular motion is increasing, the angular velocity alpha is in the same direction as the angular velocity omega. Question number 5. What happens if the angular acceleration alpha has a component perpendicular to the axis of rotation? Option A, the magnitude of angular velocity will change. Option B, the direction of angular velocity will change, causing a change in the plane of rotation. Option C, the motion will become uniform. Or option D, the speed will remain constant. And the answer is option B. The direction of angular velocity will change, causing a change in the plane of rotation. Explanation. The text says that if the angular acceleration alpha has a component perpendicular to the axis, it will change the direction of the angular velocity omega. Since omega is always perpendicular to the plane of rotation, this change in direction will also change the plane of rotation. Question number 6. If the angular acceleration alpha is constant in magnitude and always perpendicular to angular velocity omega, what will happen? Option A, only the magnitude of omega will change. Option B, both the magnitude and direction of omega will change. Option C, the direction of omega will change but its magnitude will not. Option D, the plane of rotation will remain the same. And the correct answer is option C, the direction of omega will change but its magnitude will not. Explanation. The provided text explains that if angular acceleration alpha is constant in magnitude but always perpendicular to angular velocity omega, it will continuously change only the direction of omega and never its magnitude. Question number 7. What is the formula of centripetal force, which is denoted by CPF? Option A, CPF is equal to m omega square r. Option B, CPF is equal to m a r. Option C, CPF is equal to minus m omega square r. And option D, CPF is equal to minus MAT. And the correct answer is A. CPF is equal to m omega square r, and its explanation is the centripetal force, which is denoted by CPF, is the force that provides the centripetal acceleration, that is AR is equal to omega square r. Using the formula, we know that F is equal to mass into acceleration ma. The centripetal force is calculated as, by substituting the value of AR is equal to omega square r, we will get F is equal to m omega square r. Question number 8. In a non-uniform circular motion, what is true about the magnitude of the radial acceleration, which is denoted by AR? Option A, it is constant. Option B, it is not constant. Option C, it is always 0. Or option D, it is constant and equal to tangential acceleration. And the correct answer is option B, it is not constant. Explanation: for non-uniform circular motion, the magnitude of radial acceleration, which is denoted by AR, in some text it is written as AR, or in some text it is A suffix R, so don't confuse. It is the same thing, is not constant. Question number 9. What is the angle in radians through which the blades of a fan moved while stopping if it completed 21 rotation? Very important. What is given? It is given 21 rotation. So option A, 21 pi radian. Option B, 42 pi radians. Option C, 21 radians. Or D, 42 radians. And the correct answer is option B, 42 pi radians. Explanation: the angle of rotation theta is given by the formula theta is equal to 2 pi n, where n is the number of rotation. Here it is given, the rotation is 21 rotation. By substituting, we will get theta is equal to 2 pi into 21 is equal to 42 pi radians. And the last question of this series is question number 10. When angular acceleration alpha is constant and along the axis of rotation, what can be done to describe the motion? Option A, only vector notation can be used. Option B, scalar notation can be used, and kinematical equations analogous to translation motion can be applied. Option C, the motion cannot be described using standard equation. Option D, it is described as a uniform circular motion. And the correct answer is option B. Scalar notation can be used and kinematical equations analogous to translation motion can be applied. Explanation: when the angular acceleration alpha is constant and directed along the axis of rotation, all vectors are aligned. That is, theta, omega and alpha are aligned. This alignment allows for the use of scalar notation and the application of kinematical equations of motion similar to those used for translational motion. So, the correct answer is option B.